Hello, we're students with the Center for Applied Mechatronics at Alexandria Technical and Community College, and this is the Quad Shot Beverage Dispenser, our senior project for this year. We had 8 weeks to design this project and 6 weeks to build this project this semester. I'm Kyle. I was our electrical and PLC specialist for the project.
I'm Kayla. I was in charge of the pneumatics.
And I'm Justin, and I was in charge of mechanical design. So I was in charge of the mechanical design for this project. I was tasked with building and constructing the framework and the rest of the machine for the project. I also inserted components that I got from my lab partners, made adapter plates, and other things that have to go along with mechanical design. For an example of inserting components, I made most of this most of this panel that I was given to by my partners. Some of the adapter plates that you see here, and also inserting our water solenoid valves for the project.
Alright, I was in charge of the pneumatics for our machine, and so during our design phase I spent a lot of time doing calculations. Those included the CFM, CV rates, pressure, force needed, and inches HG, which is inches of mercury for our vacuum system. And once I had all of those calculations, I found components that would match those and were compatible with each other. After that, I made a 3D printed vacuum adapter for our vacuum cup. And lastly, I built a schematic. We started with our horizontal cylinder that has one reed switch, is a 1/4 inch bore, and 2-inch stroke. It has one flow control meter out. Our vertical cylinder has 2 reed switches, meter out both directions for flow controls. Our rodless cylinder has 2 flow controls, meter out, is a 25-inch stroke, and has a 3-position valve, so we could have the closed center and it would center. Our Venturi system has a vacuum switch, Venturi, and a 1/4 inch vacuum cup.
Right, I'm Kyle. I was our PLC and electrical programming specialist. And here is our program for the machine. There are a total of 41 lines of code for this machine, ranging everything from handling the lighting system to our valves, which will dispense our drinks, up to our pick and place system. Overall, it's a relatively simple program. We use various counters and timers to track certain machine actions. We use a counter for our manual mode and timers throughout the machine to denote when things should happen. As for our electrical schematics, we have Adobe Acrobat, the best thing ever, clearly. It's not. Our electrical schematic is pretty in-depth. We have our main PLC, the Allen Bradley Micro 820, with all of our push buttons, selector switches, and proximity sensors. Our valve, 7 of our 8 valves are handled by the main Micro 820, and all of those valves are run through an e-stop circuit. We have both expansion cards filled with the IEQ4 OB4s, which are 4 in, 4 out, digital. The first one has our remaining cylinder switches and vacuum switch, as well as our 3-position valve solenoids, which are also routed into the same e-stop circuit as the first 7 valves. Our second external module has the light circuits on it, and that is all.
For this video, we have the quad shot in the manual program, which requires you to hit the start button for each move of the process. However, switching the selector switch to auto will switch the machine to the automatic program. To start the machine, you hit the button of your beverage of choice, then you hit the start button. The machine starts with a pick and place, the vacuum turns on, and the vertical cylinder extends, then retracts, grabbing a cup. A reed switch is made sensing that the vertical cylinder is all the way up, allowing the horizontal cylinder to extend. Once the horizontal cylinder is extended, with the cup directly over the carrier, the vertical cylinder once again extends and the vacuum is shut off. Once the vacuum is off, the cylinder retracts, followed by the horizontal cylinder doing the same, putting the pick-and-play system in the home position and leaving the cup on the cup carrier of the rodless cylinder. With the cup on the carrier, a sensor is made, sending the carrier to the station of your chosen beverage. Once the cup is at the station, a sensor is set off that stops the rodless cylinder and opens the line to allow the beverage of choice to flow into the cup. Once the cup is full, the line is shut and the carrier with the cup is sent to the end of the rodless cylinder where you can pick up a cup of your drink of choice. The cup arriving at the end of the rodless cylinder sets off another sensor that, once you've picked up your drink, shuts off, sending the carrier back to its beginning position, making the machine ready for another run.